This segment of our show is sponsored by FARO, the world's most trusted source for 3D measurement and imaging solutions.
Well, now we're going to turn to another close-up look at an important class of test and measurement equipment, in this case the Quantum S ScanArm from FARO Technologies. Now, FARO was one of the originators of articulating arms, also known as portable coordinate measuring machines.
PCMMs?
PCMMs, that's right. ARMS first took high precision inspection right out onto the production line back in the 1980s. And joining us now in the studio to look at the Quantum S ARM is Rafael Hasbun of FARO Technologies. So thanks for joining us, Rafael.
Hey, it's my pleasure, guys.
Of course, of course.
Now, before we take a look at the Quantum S, just in general, I mean, for people who maybe looked at portable arms 15, 20 years ago. I mean, they've actually been around for quite a while, and then dismissed them as being too inaccurate, too cumbersome, you know, just didn't feel like they had the accuracy and the speed that they needed for what their applications were. That has really changed a lot in the last 10 or 15 years, right?
Definitely. FARO's been in business for over 30 years, and through each iteration of their arm, they've pushed the envelope. Especially with this new Quantum S, it meets the ISO 10360 standard, which we can get into a little later. But that's the toughest standard up to date for arms in general. And currently that's the only arm that meets that standard, and that's, again, a very rigorous test and a testament to the capabilities of an arm. And I myself have implemented an arm into various manufacturing processes in many different industries: aerospace, automotive, forensics, wide variety of applications.
That's great. That's great.
Well, why don't we run the demo that you recorded with us with your colleague Mike Koski yesterday, and then we'll come back and take some questions on the Quantum ScanArm. But remember, send your questions to QDL and send them right away so we get them. QDL@qualitydigest.com, or you can tweet at Quality Digest, or you can use the chat feature. So as you think of those questions, don't ponder them and finesse them, just send them to us so that we can actually ask Rafael while he's on the show. Let's run that clip.
Thanks.
So guys, we're going to be looking at the Quantum S, the FARO Quantum S ScanArm. Is that what you call it, a ScanArm?
Correct, yeah. This is a ScanArm. It's the latest release from FARO, our most accurate arm ever. We'll show you guys what it can do with the probe as well as the laser scanning. You can use those, you can hop between those two rapidly in the software.
And you got both the probe and the laser scanner, both on the same
they're both
tip.
They're both. So yeah, this is our probe. That's our laser scanner.
And the best part about that too, just to touch base, is kind of a hybrid solution. So you have the ability to swap back and forth extremely fast. Use the touch probe for a little bit better accuracy, and then you can also take off the scanner as well. It's detachable, so if you have to probe and get into tougher areas, you have the ability because it has the buttons on top as well.
Okay, gotcha.
Right on. So what we have here is our Cam2 Measure 10 software. That's FARO's proprietary software, and the ARM is capable of running on many third-party softwares.
Sure.
So what we'll do here, we have our CAD model in the software, and we're just going to go ahead and align to that. You'll see Mike using our probe. So this is a contact-based measurement, right? Probe is physically touching your part. That's our 6mm probe, and there's a 6mm and a 3mm included with the arm. Beyond that, there's many different extensions and different probe sizes that you can get.
Okay, and tell us a little bit about probe calibration.
Right, so the probe, you need to calibrate it the first time you use it. That's the beauty of the Quantum S. It's going to remember the calibration for that specific probe, for that 3 and 6mm probe. So you can swap those very rapidly without needing to recalibrate each time you swap.
So that'll make it nicer and faster for an operator to get their inspection done quicker.
Sure. Yeah. They can just put the probe in. The electronics recognize the probe, right, and then it loads the appropriate calibration information for it.
Correct. And you just switch it by using this top handle, which detaches.
It pops out. Okay.
Pops out.
Right.
Yeah. So Mike, if you go ahead and measure some circles, and what we're doing here is just a very typical inspection. The probe operates very similarly to a CMM, right? So it's just handheld, and the beauty of the arm is portability, right? That's what we're really trying to stress with our arm. You can take this inside the shop, you can take it into the metrology lab, you can take it inside, outside. There's internal temperature compensation, so that's what one of the main keys that makes it very portable.
It's basically moisture and dust proof and all that kind of good stuff, right? Okay.
Everything's enclosed in the arm, so you're not going to get any dust or dirt. So we specifically made it for the shop floor, and especially with companies, manufacturing companies that are in different environments, or whether it's winter or summer, it really is able to compensate and provide the consistent, accurate measurements all the time.
Cool, and just to keep you guys up to date with the inspection, what we have here, since we're aligned to our CAD, it's going to grab all the nominal data from the CAD model. You still have the option to type in nominals from your prints and stuff like that. Just importing the CAD helps speed up the process. So we were able to generate this bolt circle by measuring a few features there, and you'll see this XY position data as well as the diameter data automatically filled in and compared to your CAD. So you'll see things within tolerance show up in green, and things out of tolerance will show up in red or blue.
Okay, so one looks like that's a circle, right? The red is one circle that is out of tolerance then.
Right, so
In
here,
the lower right corner, okay.
yeah, it's saying similar position is out of tolerance.
Okay.
Right, so from there we'll go ahead and measure a few planes. I'll show you guys. It's very simple to grab angle measurements as well as different distances and things of that nature. Very versatile inspection program we have.
So right now we're just inspecting to CAD, and as he's taking the measurements, it's I notice it's actually recording the sequence of each of the measurements that he's taking.
Correct.
Yeah.
So one of the greatest capabilities of CAM2 is once you inspect your part the first time, you can build a program from that initial inspection that you can then run through very rapidly, and it'll guide an operator through hundreds of different parts, or the same part 100 different times.
Yeah. So the next person would come along and it would just tell them,
Yes.
measure this circle, measure this circle, measure this plane. Okay.
Yeah.
And that'll make it so much easier for any kind of operator to come up and just take the arm up and measure a part and get it done a lot faster.
Yeah.
as
The
well.
screen will tell them, go here, right?
Right.
Yeah. Measure
Right.
this. Measure this plane. Okay. All right.
Yeah.
Yeah. So what I'll also show you guys here in our software, you can inspect to surface since we have our CAD model in there, and that's still using the probe, right? So if you have something that's very freeform, we'll switch over to distance interval mode, and it's actually going to inspect the surface profile of our part using the probe, comparing it to the CAD. So that's what you'll see there. That green surface it's following the path that Mike scrubbed on our
So
part.
basically, rather than points, it's actually almost like working like a scanning probe.
Yeah, we're using the probe to scan and take a bunch of points very rapidly.
Okay.
Right.
And after you're done, you could save all that information in a PDF, Excel, Word, text file, and be able to send that internally to people inside the company, or of course to suppliers, and use that almost as a traceability if somebody needs to verify and see, hey, does that part pass or fail?
So you can spit out a report as a PDF or something and have all this same information on it.
Right.
Okay.
Everything that we just
inspection
recorded.
information. Right.
Yeah.
Okay. Perfect.
Cool. So up to this point, we've just been using the probe, but now we'll jump in and use that laser scanner. What you'll see pop up is our blue light laser scanner. So
it's got an indicator here. That's kind of the operator range. So when I get too close to the part, it turns red. When I get kind of at a medium range, we're looking at a crosshair. So when those two line up, the laser and the crosshair, we're in perfect range to start scanning, and you can see it on the
Yeah, I can't quite see it in this view, but I can. Yeah, I can see the blue laser, but from here I can see there's a red crosshair. Yeah, exactly. Yeah.
So since we're aligned to our CAD, when he's scanning our part, you'll see that color map pop up, and that's a real-time comparison from our CAD to the scan data.
So I'm collecting the laser scanner itself. The FARO Blue collects 600,000 points per second. And it's about almost a 6-inch laser stripe, so you're getting a lot of coverage, being able to inspect organically shaped parts a lot faster.
And I noticed you went right from probe to scanner without, basically you just change modes, right? There's nothing fancy you have to do. You just say, oh, I'm going to use a scanner now.
Exactly,
Okay,
yeah.
okay.
So that
And
makes it a lot
aligned and-
more
okay.
streamlined, and,
Yep.
and you really understand how a part's behaving fully because you get your data on the CAD model, and then you get the tolerance band as well. So you can adjust that based on the tolerance of the part.
Okay.
Right, so that's what you see with our that color map there.
Okay.
And again, so the beauty of that point cloud is it's going to help you inspect freeform surfaces that you couldn't really inspect prior to that.
And by what was the accuracy of the system here?
So with the laser scanner, you're looking at a 1.9 thousandths repeatability.
Okay.
And just probing, it's 1.3 thousandths.
Okay.
Right. So what we'll do now, again, since we have that blue light laser scanner, I'll show you how we can scan shiny surfaces without the need to coat your part or spray it with any kind of coating.
And we have a shiny surface right here on
Yeah,
the,
just a diamond plate here.
And that was the biggest challenge for a lot of our customers, is just being able to scan optically challenged parts. And so FARO came out with this new blue laser, so it's able to capture the data in real time as well.
Yeah, it looks like you're just scanning that just fast as you want, huh?
Yeah. Again, it's capturing a high amount of points very rapidly.
Yep.
And you can always adjust that in case you're doing a large scan. You might want to turn down
if you don't
the
want,
amount of data.
Yeah, if you don't want
at the computer.
600,000 points a second, don't need it. Yeah.
So that's
And
the,
there it is. Okay. Yep.
that's the data we were able to collect. And
Pretty
that was
easy.
in real time on a shiny surface, right? So the beauty of scan data, like you saw before, you can use that to compare to your CAD model, or you can also generate a CAD model through reverse engineering softwares.
Okay. And so this was the Quantum S ScanArm.
Correct.
I got that
Quantum
right?
S ScanArm. Yeah, you got it.
All right.
2.5 meter.
Well,
Yep.
oh, and by the way, what are the different sizes?
So it comes in 1.5 meters, 2.5, 3.5, and 4 meters, which is FARO's largest arm.
That's a big arm.
Yeah.
All right, Rafael, Mike, thanks a lot.
Yep.
Thank
Have
you.
a great day.
Okay.
Thank you.
Yep.
Yeah, really cool demo there. Good job, Rafael and Mike Koski. Of course, Mike couldn't be with us today, but Rafael is going to sit in and answer your questions. We're getting some questions in, which is good. But I want to remind you all, we're going to have Rafael for the next maybe 15 minutes or so. Get your questions in now. If you do have some more, QDL@QualityDigest.com. Again, you can hit us up at Twitter at Quality Digest, or just use the chat function on your screen. So get those questions in as soon as you can.
All right, let's take a look at that first question.
Yep, let's look at it.
How is it an enclosed system? Doesn't it have a fan to cool the laser? What comes with the system to verify it meets the accuracy spec that you claim?
That's a very good question. So it's an enclosed system. There's circular encoders in each joint of the arm, and they're dust proof. They can operate in up to 95% humidity. The laser does have a fan. It is throwing a lot of data at not only the computer, but going through that system to capture that data. So there is an internal fan in the laser to help maintain the heat. And what comes with the arm is a calibration cone to validate your probe, as well as a plane that you can use to measure and make sure that your laser scanner is measuring correctly as well. And the arm comes with a 1-year warranty, which will include a 1-year certification, which is NIST traceable.
Wonderful. And I believe, just kind of repeat one of the unique things about the calibration, in case they didn't catch it, is that I believe you said you calibrate once, and the calibration information for that probe tip is now stored within the system itself.
Correct.
And it recognizes the probe.
Right. With the new Quantum, you only need to calibrate your probe once. It comes with a 6mm and a 3mm. And you calibrate those the first time you're going to use them, and then you can swap those and you won't need to calibrate. So that really helps speed up the inspection process without the need to go into the software and recalibrate your probe each time. Now the laser, as long as you don't take it off, it'll stay calibrated. But you do want to recalibrate the laser every time you take it on and off the system.
Okay, so you mount the laser there, you calibrate it, and then as long as it stays attached,
correct,
then it's calibrated.
Right,
Okay.
and with these new probes, there's actually an adapter to use old probes, so your old probes are still going to be able to use those in your inspection process. And there's a wide catalog of different probe attachments, different extensions that you can use for very specific applications.
But old probes you would have to calibrate each time, is that
Yes,
right?
indeed,
Okay,
yeah.
okay, all right,
Yeah,
okay.
it doesn't have the electronics in the newer probes.
Okay,
Right.
let's see another question.
Cool. Yeah, I'll take this one. Let's
All
see.
right.
Boy, that's the hard one. What lengths does the Quantum S arm come in?
That's a great question. So there's
This long and this long.
yeah, right about here, you know. So there's 4 different lengths: 1.5 meters, 2.5, 3.5, and 4 meters, which is actually FARO's longest arm to date. It comes in a 6-axis variant and a 7-axis. Now the 6-axis is going to give you higher accuracy, but no capabilities of attaching a laser scanner. So with the 7-axis, you get the ability to attach a laser scanner. So, and like when we mention length, you're not limited to the length of the arm, right? You can leapfrog the arm. So if you're measuring something, let's say that's beyond 4 meters, you can move the arm around. That's really where the portability shines.
Is there tolerance build up when you do leapfrog like that?
Yeah, when you do a leapfrog, there's going to be a varying accuracy that you might lose, but it's manageable, and there's a few ways you can help reduce that.
Okay. All right, next question. FARO is touting the ISO
Just talked about that. Yep.
10360 specification for calibration. What's so great about this, and why is it better than B89? The old, B89's been around a long time.
Yeah.
It has indeed. So that's a very good question. I touched upon that right at the intro. So the 10360 standard is just a new international standard, which requires 5 different measuring tests, whereas the old B89 would only require 2 measuring tests. So FARO's Quantum S is the only arm currently on the market that reaches that ISO 10360 standard. And again, those 5 tests it's 5 different articulation points that it puts the arm through. So it's a much more rigorous test, and there's no way to hide any accuracy issues that are inherent in the arm.
And let's back up, because I meant to ask you this earlier. So when they say 6-axis and 7-axis,
Sure.
Can you, because that refers to where, so you got like the shoulder, the elbow, and what are all the, because I can't even come up with 7, I mean, where are they at?
Sure. So it has to do with all the different joints in the arm. There's a joint at the base, one at the elbow. So basically what you have with that 7-axis is the rotation of the probe piece, basically. So why you have 7 axes, it just makes it more ergonomic, and especially when you're laser scanning. It makes it easier to handle the laser scanner.
Okay. So maybe even get to
any angles
stuff that you wouldn't get to with a 5-axis or 6-axis.
Exactly.
Okay. All right. Okay. Got it.
And this technology goes back, as we mentioned in the opening, to the 80s. I mean, this has been the general ARM technology has been around for a long time. If you visit FARO's offices, you'll see kind of their wall of history there of all the different arms. I believe it started out in the dental space.
Yeah, so FARO stands for Fraser and Rabb Orthopedics. So their first products were geared towards the dental industry.
How funny.
Yeah.
Kind of cool. Yeah, if you go, I think we've been there.
Yeah, we've been there.
Yeah, it's a really cool facility. You see all the different arms throughout the years from the 80s until now. It's pretty cool stuff. All right, well, let's take a look at the next question. Let's see. I'll take this one. So does it come calibrated, ready to measure right out of the box?
Right, so like we got into before, you're going to want to calibrate your probe and your laser. Again, the new probes that come with the Quantum, you calibrate them once, and then those will be ready to measure. And calibration takes a few minutes. Very simple process. It comes with the calibration cone. Everything you need is included with the system. And again, those NIST traceable certifications are available once a year, and as long as you maintain your warranty. But yeah, it's pretty much plug and play system.
And how often does the arm itself need to be calibrated?
We recommend once a year.
And it's something you can do, or do you send it back to FARO?
We recommend sending it back to FARO, but usually there are local operations that'll calibrate.
That can do it. Okay.
That can calibrate your arm. But FARO's is NIST traceable, so that's something to keep in mind if that's what your company is looking for.
So that, again, ISO 10360. Is that the standard we're talking about here? And when was that standard? When did that come out? 2016. Okay. Oh,
so very recent.
Just a recent standard. And the B89, we said, had been around for a while.
Yeah, B89's been around forever. I think B89 was originally a CMM. Was for regular CMMs, and so it's been around since beginning of time, I think. And somebody will correct me on that, I'm sure.
Yeah, right. It's QDL.quality.com. Let us know if we're wrong on that. But yeah. So before that, there wasn't really even an understanding. I mean, B89 goes back to the dawn of this technology. Is that correct? When you say the beginning of time?
I think B89, and I'm really going to get myself in deep water here. I believe B89. You can correct us on this. B89, I believe, is a standard that goes back to kind of the beginning or early days of CMMs. Regular CMMs.
Okay.
Yeah, not anything to do with portable arms. It was kind of adapted, so to speak, I think, if I'm getting this right, to kind of encompass portable measuring equipment. But it was really designed, I believe, for, notice all my little wiggle wobble words there. I believe B89 was for traditional, fixed CMMs.
Which I believe goes back to the 60s?
In the earlier than that,
50s, wow. Yeah. That's amazing. The technology's been around that long.
Before we say any more, let's shut up.
Let's move on to the next question. That's right.
You guys are really off.
Right.
We only pretend we know what we're doing on television. Okay.
All right.
You've indicated that the Quantum S is very rugged. Can you elaborate on that?
Yeah, so before we ship out every arm, it goes through a series of ruggedness tests. So we do temperature cycling from -5 degrees Fahrenheit all the way up to 140, which should cover the vast majority of operating temperatures, I imagine. Okay. We also do a vibration shake test, right? So we just shake the arm for a while, make it dance, right? Then we do a drop test. We drop it at least 4 times in the case, and then we do a recalibration and make sure it's measuring within standard after all those tests. So again, this has been battle tested and proven to withstand anything you're going to throw at it.
Yeah, I mean, you mentioned in the case, because we should say that this is stuff that it's intended to be shipped and carried and put in the luggage on a plane and that sort of stuff, right?
Correct, yeah. The arm comes in a Pelican case, and we ship it through various vendors, FedEx, and it's built to withstand those different conditions.
Okay. And there's a lot of, obviously, when they get to the customer, I mean, there's all these different applications and the shop floor. I mean, so what are some of the real world applications in which that ruggedness would really come into play?
Right. Right on the machine floor, you're in process inspection. You have a lot of vibrations going on. Sure. Sometimes people might walk by and drop the arm, something like that, God forbid, right? But it's real world scenarios, and the arm is built to withstand those scenarios.
Great, cool. So I think we do have a few more questions actually, still coming in. That's great. And hey, before we even progress any further, again, guess what? QDL at qualitydigest.com is a place you can send your questions. We're going to have Rafael for about another 7 minutes or so, 8 minutes. So if you do have questions, please get them in now, and we'll try to get them in at the end of the segment. We missed a question with Eric Perkins earlier in the show.
But we'll get him to respond to you offline on that.
Well, we want to make sure we don't miss the next one. So again, QDL at qualitydigest.com, at Twitter at qualitydigest, or just chat to us with your questions. So let's take a look at the next one we do have here queued up. Okay, can you confirm the accuracy of 0.0013 inches for hard tip and 0.0019 inches for the laser? What about touch probes? Good technical question. Can we throw that one back up there? Yeah, there we go. Okay, cool.
Yeah, so again, that accuracy is spec'd out to that new ISO standard. And you can confirm this on your own with a gauge block, if you will. You know, we measured that a few times, and you know, once you get your arm, you can verify that it's within spec, and that's the volumetric accuracy, right? So that's moving the arm through its entire range of motion. So I'm not too sure. So touch probes.
So they were talking. I think because
like
I believe you
probes?
said in the video your accuracy was 1.3 thousandths for touch probe and 1.9 for the laser scanner, right?
Right.
I think they're just saying how do you confirm that? Which I believe you just I mean, that's through your calibration. The calibration's NIST traceable.
Right.
So yeah.
Yeah, and to speak to the calibration of the laser specifically, to get that number, we measure a sphere of a known size within 5 different articulation points, and that's how we come up with that number. And these numbers are worst case scenario. If you're with proper technique, you'll see even better accuracy results in your real process inspection.
Okay, cool.
And the Quantum S, I mean, now that's pretty much brand new, right? I mean, how long has it been out?
A few weeks now.
A few weeks.
Yeah,
Wow. Okay.
yeah, very new.
This is one of the first demos anybody's ever seen of this product.
Yeah, yeah.
And so what the prior generations? I know we kind of went through this on the video, but the prior generations, the upgrade that went into this.
Sure.
So what were some of the changes and the upgrades that actually you saw on the Quantum S?
So the previous arm was a FARO Edge, and that came out 7 years ago. So you know how technology progresses so much nowadays. Yeah. But there's been a 25% reduction in the weight, so it's a lot more ergonomic. It feels like it's an extension of your arm, whereas the previous arm could get a little fatiguing. Not to say it was hard to handle or anything, but that's just one of the advancements. As well as a bump in accuracy, and as well as data capture for the laser scanner. We're able to capture laser data 5 times as fast as before. So again, there's also shock absorbers in the arm for setup. So that lightness really helps with the portability, which FARO is all about. We're not trying to replace your CMM. We want to work with your CMM, with your current inspection process.
Okay, I believe we have another question.
One more queued up. Let's take a look here.
If 3D volume accuracy is 1.3 thousandths and 1.9 thousandths, hard tip and laser respectively, what about measuring flatness or concentric features?
So basically, all that is calculated in your software, right? And the arm works with a variety of software. So each point that you measure with the hard probe or with the laser will be within the specs that we state, right? The 1.9, the 1.3 thousandths.
And I think what may be getting confusing here, and correct me if I'm wrong, I think when you're talking about a traditional CMM and you're measuring so they have there were 2 different specs. There used to be a volumetric accuracy, and then I'm not sure whether a point accuracy. Because you would have maybe only move one stage. You'd move it, only one axis would move. Right? But with an arm, all of the axes are always moving, so it's always basically volumetric accuracy, I think. I mean, that's all it's doing is volumetric accuracy.
Yeah, it's measuring in 3D space, right? So that flatness that you get a call out of, it's going to be based on the average of those points that build your features. And that'll speak to what flatness reading you'll get, and then what concentricity measurements you can get.
Okay. Great. And any inaccurate information that I give is totally Quality Digest and not Farrell's or Sterrett's.
Thank you for doing that, Dirk. Appreciate that. I think we do have one more. Yes, we do. Okay. They're coming in good, and please keep on sending them. All right, so Rafael, you mentioned the blue laser a lot. Specifically, why is a blue laser better than other colors? Good question.
Because they're all actually green and
red.
Yeah.
Yeah. So that's a great question. So with the blue, let's say compared to a red wavelength scanner, the blue has a shorter wavelength. So what that allows is reduced speckle, greater detail capture, and as well as one of the greatest benefits is you can scan shiny and chrome surfaces without the need of any sprays or any kind of coating, powder coating to get that. So so that basically improves your scanning rates, and it allows, sorry, so it lets you basically capture the data a lot faster in the process.
All right, cool.
And I think, did we hear? We don't have any more.
No more.
Great. Okay. Well, that's great. Well, Rafael, I mean, I think that was a really good look at the Quantum S from FARO, the ScanArm.
One other technology. Where are you seeing this mostly used? Where is the interest in this product from what you're seeing? Shop floor, CNC shops? I mean, where is this?
Yeah, I've seen it all over the place. With the hard probe, you see it a lot in inspection. With the laser scanner, you see a lot of reverse engineering applications. So in a wide variety of industries, but manufacturing is where it stems from. So it still has a very high presence in the manufacturing world. So any kind of, like I said, in-process inspection, first articles inspections, those are where one of the biggest industries that you'll see the arm in.
Perfect. Well, thanks, Rafael.
That's great. That's great. Well, thank you for being here, Rafael. Sorry we had to miss Mike Koski, but you guys did a great demo. Again, of the Quantum S ScanArm from FARO Technologies right there. And again, if we missed your question, or if you're still getting questions in like we had on our last segment, we will definitely be forwarding them on to...
Rafael will be here at the end of the show.
He will be, that's
if they're
true.
related to the arm, we'll still be able to get
We
back
can still
to
get them on.
Yeah.
So yeah, keep on getting those questions in. It's really good to have that kind of interaction with the team here. So if you have questions, send it in. Again, Quality Digest, QDL@QualityDigest.com. At Twitter at Quality Digest, or just chat them out to us. All right, well, we are at the end of this segment of our expo. Before we move on, of course, we want to thank our sponsor, FARO Technologies. FARO Technologies is the world's most trusted source for 3D measurement and imaging solutions. FARO hopes you enjoyed learning about their new Quantum S ScanArm, which we just looked at here with Rafael. Ask FARO to set up a customized demo for you, because you've got to give the Quantum S a try. And FARO is the measure of success. So for more information, visit online at www.faro.com.